4. So dp side over dt comes out to be 0.174 bar over Kelvin. So so you already got 3223.6 cubic centimeter per mole multiply by 0.174 bar over Kelvin. So if you multiply this value into 323.6 562 so 562.03. You can just double. I don't have calculator, I just use the mobile. It comes out to be cubic centimeter bar over mole Kelvin. So don't forget to convert this cubic centimeter bar into joule. We just need to divide by 10. So you can see here, you can just divide by 10, like you know the value of so you know already, so 83.14 cubic centimeter bar over mole Kelvin, and here is 8.314 joule per mole per Kelvin. So mole Kelvin. So this cubic centimeter bar. So if you see, there is a factor of only 10. So if you divide by 10, so it will give you 56.2 joule per mole per Kelvin. So if you want to convert, if you want to find delta HLV, you can just multiply, delta SLV multiply by T. So I did. So 56.2 multiplied by 333.15, it gives you 18724.07 joule per mole. So this is your answer for your enthalpy of vaporization, and this is your answer for entropy of vaporization. So if I just want to tell you one thing, let's say if you want to calculate directly delta HLV, it will be T delta VLV dP sat over dt. Then this temperature always you have to substitute in Kelvin. So like in this case, so you know already this is given 333.15, delta VLV already given 3223.6, multiply dP sat over dt, we got 0.174 bar over Kelvin. So this is cubic centimeter over per mole, and this is in Kelvin. So you see Kelvin cancel out, and then again if you calculate this one, it will give you the same answer, 18724 0.7 cubic centimeter bar over mole. So if you convert this cubic centimeter bar into joule, it will give you 8724.07 joule per mole. So you have to answer, give the answer enthalpy of evaporation and entropy of evaporation, and gives energy of formation, gives energy of evaporation or whatever. you have to give in terms of joule, and volume we have to give the answer in terms of cubic centimeter per mole. So this is the end of chapter 6. So this is the last problem that I can solve. I solve for you. If let's say in exam, here instead of Kelvin you have Celsius, then you have to substitute here Celsius, then your dp sat over dt answer comes out to be, so let's say in that case Celsius, I'm giving an example, I'm just giving any example, okay. So let's say if that value is in Celsius, then your delta H will be, let's say any temperature 300. Then again you have to substitute here Kelvin, let's say 3000 cubic centimeter per mole, and the last value is 0.35 bar over Celsius. If you solve this one, it will be in Celsius, bar over Celsius. So no problem, because in dimensions you can cancel this. You have to substitute here Kelvin. That I want to tell. So this Kelvin will cancel out with this Celsius, and then again you just need to solve as it is. Convert this cubic centimeter bar into joule and solve the problem. So this is the only. I'm just giving you any suppose values just to explain to you, if just to tell you that if you got in the time question, if you have Celsius, then this Celsius will easily cancel out by this Kelvin, because in dimensions both are equally, the division is same for both. The Kelvin division is 100 from 273 to 373, and Celsius division is also from 0 to 100. So division is same, so there will be no problem in cancelling them on the Kelvin and Celsius in dimensions. So this is the only issue. You will face this problem in next problem that I already put in my slide. You can solve that problem, and hopefully this is the end of chapter 6. One last thing is, if you need to solve the problem by Clausius-Clapeyron, by Clausius-Clapeyron, I told you the Clausius-Clapeyron is, you can say CC, Clausius-Clapeyron. Len P2 said over in your course we have to only plug in the integrated form. So this is the integrated form of Clausius-Clapeyron. 1 over T1 minus 1 over T2. In that case, what you need is, this is very easy question. What you need to do is, the first step is you can select any temperature T1, let's say 25, and you have to find P1 sat. P1 sat you can find from any equation. You can find from any equation, whatever available to you. Entire equation, extended time equation, Wagner equation, Lee-Kessler, any equation you can apply, and at T1 you can get the P1. Okay. Similarly, you have to select any temperature near to this, because assumption of Clausius-Clapeyron is your delta H will remain constant whatever the temperature is. Maybe you can take 25, next you can take 26, or you can take 25, next T2 you can take 100, 100, 200, 300, 500. Any temperature you can take two values of temperature. Let's say one is 25, second T2 I can take 50 Celsius, and then I will find at this T2 I find P2 sat. Then just plug in over here, multiply by R, and I will get the delta HLV. So this is very easy question, and the Clausius-Clapeyron, because our assumption is the delta HLV will remain constant whatever the, so you can suppose any value. This is any suppose value. This is in any value, any other value. Instead of 25 you can take 26, 25.1. or 100, 200, 500, any value. But if you take the more bigger difference like 525 and 500, of course your error will be little big. But if you take 25 and 50 or 25 and 26, your error will be small. So just keep in mind that, and you can find the values of delta HL. And this is the easy way to solve problem. So the last thing that I want to tell you, now you know how to find PSAT. Now you know how to find PSAT. So whenever you solve any problem in your chapter 6 or chapter 3, chapter 10, 11, 12, 13, before starting any problem, you first have to find PSAT and compare with your given value of pressure. If pressure is greater than PSAT, it means liquid. Like I will say, find the molar volume of an butane at 20, let's say 100 Kelvin, 100 centigrade and 10 bar. But we don't know this butane is a gas phase or is a liquid phase. So that's why you first have to find PSAT. If your PSAT value is greater than P, if your P is greater than PSAT, it means you have to use liquid route. It means you can use Lee Kessler or cubic. If your P is less than PSAT, then it means you are in gas phase. Then you can use any equation, variable, Lee Kessler or cubic, depending on how much pressure. If it is pressure PSAT is above 50 bar, then you are not allowed to use. And the last thing is, if P is equal to PSAT, that means your vapor is saturated vapor or saturated liquid. For saturated liquid, you have to use racket. For saturated vapor, Lee Kessler or cubic. Okay. Or you have vary also. So we already discussed this one in chapter 3. So this is, so whenever you solve any problem in exam or in quizzes or assignment, you must have to first check, you have to find PSAT and then compare with your answer, with your PSAT value with the given pressure. If it is the given pressure is more than PSAT, it means liquid, so you have to use the given equations. Okay, so then you can solve the problem accordingly. So this is the end of chapter 6. Hopefully you understand. If you know, if don't, then you can ask me question, and I will upload also these videos and plus the lecture notes. And you also have to, I will also tell you, want you to solve some problems as assignment, and hopefully you can take the quiz as well. So let's see. Thank you very much.